Good morning, everyone. Today we are going to start with experiment 3, which is measurement of AC circuit parameters. Okay, so till now we was working with the DC voltages. Okay, so now today with this circuit here we will have AC parameters. What when if you want to represent the voltage in terms of DC, it is V equals to certain integer value volts. Okay, but in the AC you cannot represent it like this. Okay, so V of t, which is nothing but t represent continuous function of time. Okay, function of time. V is a function of time, that is amplitude Vm sine omega naught omega t plus phi of V or theta V, you can write anything. It is a phase shift. Omega is nothing but 2 pi f, where you can write it as 2 pi f or 2 pi by t, where t is the time period. Okay, f is the frequency and the t is the time period. Whereas same as I of t, that means I current is also continuous. I am sine omega t plus phi I or theta I. Okay, this is the background of the AC. So we will come to the experimental part. Okay, so what are the objectives? First of all, first of all, here you have the two new things, that is CRO and the function generator. Okay, CRO, it is nothing but cathode ray oscilloscope, and the function generator with the R frequency generator. What is frequency generator? Frequency, here you can provide continuous time signal. Okay, continuous time signal can be generated by using frequency generator or function generator. Function generator is nothing but function. So what you can generate any type of function, sine, cosine, triangular, square. Okay, with respect to frequency, with respect to amplitude, you can change everything here. This is the function generator. Next, CRO. CRO, just we will have a brief description about the CRO. Okay, and the function generator. Find the reactance of the to find the reactance of the capacitor, to describe the relation between the capacitor reactance and the capacitor capacity, to describe the relation between the capacitor reactance and the supply frequency. Okay, how the frequency, when you are changing the frequency, how the capacitor reactance is changing. To find the impedance of series RC circuit, to draw the voltage phasor diagram like this phasor diagram. Okay, to draw the voltage phasor diagram of RC circuit. Okay, to find the phase angle between the voltage and the current in the series RC circuits. Okay, so what are the main apparatus we are going to use here? DC power supply. Okay, here we can use DC power supply. Okay, the same power supply, but from as I told you in the previous class, that in the same power supply you have two parts, DC part and AC part. Okay, so then the power supply is the same. Function generator, I will just when we come to the experiment, I will show you the cathode ray oscilloscope, CRO. Just we will come to the experimental model. I will show you two multimeters. Okay, you are familiar with the multimeter and the resistor 470 ohm potentiometer. This is the potentiometer. Okay, you can write here potentiometer, capacitor in 0.22 microfarad. Okay, let us start the experiment. Okay, here something new is written, 24 volt. Okay, this is the potentiometer, 470 voltmeter and CRO. Okay, just let us have a brief description about the CRO. Okay, the device you are seeing here, it is a function generator. Okay, here you can find amplitude, offset, TTL, CMOS logic. Okay, and this is a wave function, whatever the wave we want to give from here. Let us. Okay, here you can find hertz, kilohertz and the megahertz. This here you can change the amplitude by using amplitude sorry you can use the amplitude knob to change the amplitude. Okay, so suppose here you want to give the frequency. Okay, let us click 1 hertz. So it is 1 hertz, you can see here. Okay, 5 hertz, if I press 5 and hertz, it will be 5 hertz. So here 50 hertz, or 1 kilohertz. I can provide variable frequency from by using the function generator. Okay, so by using this I can change the frequency. Okay, and here I can change the waveform. So it is now you can see here it is a sine wave, it is a square wave now. Okay, this is a triangular wave, so I can change by the wave button. This is the function generator we are going to work with. So this is CRO. Okay, so here you can see, so this is the power button. Okay, this power button is used to just display on or off. Okay, here you can find channel 1, this is the channel 1. Okay, this is channel 2, so you can find CH1, CH2. The wires which are connected here, it is CRO probe. Okay, this is the voltage knob where you can if you rotate this knob, you can control the voltage of the channel 1 when the wire is connected at here. When you want to connect this, okay, you want to work with the channel 2, you should vary the voltage here, and this is time per division. Okay, this is common for all. Okay, if I am using channel 1, suppose, then channel 1 light will glow here. Okay, so this is channel knob, channel 1 knob. If I press this knob, the channel 1 will be on. If now I just press channel 2, this light is on. Okay, so you can just see, zoom. Okay, now the your waveform is there is no waveform. Okay, this is the ground. Okay, this each box, so you can see some marks here. Okay, these are, this is 1 centimeter. Okay, here you can find the voltage and the current. So here at which channel you are working with, it will be displayed channel 2, 5 millisecond and 10 volt. Okay, so this is at the ground. Okay, this line means we are not yet connected anywhere. Okay, so let us see channel 1. Okay, now channel 1 is we are working with the both channel now. Okay, so you can find two lines here. So when I press channel 1, okay, both lights are on. So this two waveform indicates two channels. Okay, channel 1 and channel 2. And now it is a straight line, that means both are in the ground condition. Okay, now we are working with channel 1. Okay, so one line again, so I will set it. Now this is the CRO probe, you can just have a close look at it. So, probe other end is, this is the black, which is a common, and this is a so now just I will show you the probe. Okay, how it is. So this is the black one. Okay, so this is the common one, same like what we use in the multimeter. Black is the common and the red one is positive. Okay, so here it is like a shape of a pin. Okay, this is two type of a probe you are here. Okay, the black one is common in the both thing, and the red one, it is in the pin shape, and here it is also, it is the same way like a clip. Okay, so these are the two type of the probe. This is one probe and this is another probe. Okay, black and red, this is one type of probe and this is other type of probe, the pin and the black one clip. Okay, I just connect it like this. Anywhere you can connect it in this fashion. Here if I connect the clip like this, okay, so it will be like a common connected to the potentiometer. This is a potentiometer. Okay, you have seen this in the last class when we work in the laboratory. Okay, 470 is a potentiometer. So let us start the experiment. just like as I told you, each box is of 1 centimeter. Okay, and here you can see this each line is for 2 mm. Okay, so this is 5 lines from this to this point, it is 1 centimeter. So here you can see 10 volt AC. When I change this knob, here the voltage is changing. Okay, you can see, you can find something here like a wave. Okay, why I'm just reducing the voltage, the amplitude factor, the multiplication factor I'm reducing. So now if you decrease the time also, it is 10 millisecond now. If you decrease the time, it will come closer. Okay, so it is sampling at 10 kilobits per second. Okay, now if I change, now if I rotate this time, so you can see something. Okay, it is fun working with the CRO. So you have to be careful while working with the CRO, because these, if the probes are not connected properly, you will not get the output properly. Okay, so it is not output, just it is a simple sine wave generated sine wave. So here the voltage is 0.1 volt AC. Okay, you can see here, and 20 millisecond. Previously it was 10, just we change it the knob, so it becomes 20 millisecond. Okay, so suppose if I want to take the amplitude here, okay, if I suppose this wave is starting from here 1 2, and what is the point here, 2.2 around. Okay, 2.4 into 0.1. okay, whatever it is, that is the voltage. And if I want to take the time period, so if you see the wave, this from this peak to this peak, it is approximately, from this peak to this peak, it is approximately one box. So 1 centimeter, 1 into 20 millisecond becomes 20 millisecond. 1 by 20 millisecond, that means if you want to take the frequency, 1 by 20 is that much hertz. Okay, okay, this is the peak to peak. When you take two peaks to peak, multiply with this is the time period. Okay, this is the time period. Okay, and this is the voltage. This is some example waveform. Okay, it is not for our circuit. Okay, as you know, we worked with this in the two previous experiment. Okay, with this device, in last two experiments. This is the power supply. Okay, so when I connect between these 2 points, okay, that means blue, these 4 knobs is for the DC. Okay, so this is fixed to 15 volt, 12 volt. Here it is a variable 12 volt. Okay, if I just remove it, it is variable 12, fixed 12, 15 volt. Okay, from the knob I can change the DC value. Okay, this is the DC, and here it is, this is the AC parameter. Okay, AC voltage supply. So here it is 12, here it is 12. Okay, so this line indicates, that means if you short these two, from this side, means that means if I connect from one wire from here to here, then this become 24 volt. Okay, AC, 24 volt AC. So this becomes 24. Okay, let us connect the wire and make it short. Okay, anywhere, if you connect this way or this way, these two or these two, it will be short. Okay, now it becomes 24. So our basic circuit is 24. Potentiometer, voltage source, this is the potentiometer for 70. I can change. So I can take the other component from inside. So let us start the experiment. Okay, here it is 24 volt, 0 potentiometer, voltmeter and CRO. So let us connect here. Let us short this. It becomes 24. Okay, so when we short these two, if I take output from here, it is 24. You can do either way. Okay, you can connect this or here or here. It is the same thing. So let us connect from supply to the 24. Okay, so to supply to the supply to the potentiometer 1 end. This is the potentiometer 1 end. Okay, and from potentiometer other end it is connected to the voltmeter and CRO. So potentiometer 1 end it is connected 124. Okay, and from this point we are connecting to the voltmeter and CRO. Voltmeter, okay, and common to the voltmeter. From this to voltmeter and this to voltmeter, and from here from this yellow line wire we will connect to the CRO. Okay, so this point, you can see this point, it's connected to the red, and this is the black one, common, it is connected to the common. Okay, from here it is connected to the red wire is connected here, and the black one is connected to the common 0. Okay, so from here we are connected to the common, and here it is the red which is connected to the one end of the potentiometer. Okay, let us see the waveform here. Okay, so here we are working with channel 2. Okay, we get some waveform. Okay, what is that waveform? Here we have 2 volt and 20 millisecond. Okay, what is 2 volt? 2 volt is the amplitude. Okay, not exactly this one. Okay, just let me explain it. So what is the deflection coefficient? Okay, deflection coefficient is nothing but we will count the number of boxes. That is the deflection coefficient. Okay, multiply with this. Suppose our waveform is starting from here. Okay, let me set it for you properly. Let us shift it properly. Okay, now you know that we have, I just in the first class I told you it is AC and DC. Now when I press this button, the voltmeter becomes AC. So now when it is AC, you will see some value here, that is 2.79. This value is nothing but RMS value. Okay, what is the value you are seeing here? It is RMS value. Okay, 2.79 is RMS value. Okay, here you have peak to peak and RMS value. Okay, so peak to peak you will get from the CRO, and the RMS value is 2.79. so if I just take RMS value, just directly I can take 2.79. if I want to take peak to peak, and we can convert it to the RMS. Okay, now I will set it to the 3 volt as in the tabular form. You can see it is a 3 volt here. Okay, when it is 3 volt, we set it to 3 volt, then let us count, just shift it properly. So here you can see, let us this is 3 RMS. Okay, here it is RMS value what we set in the multimeter. So this is DC, deflection coefficient adjusted. Deflection coefficient adjusted is here in the CRO. In the CRO you can find this. Okay, this is the deflection coefficient 2 volt suppose. Okay, now we will write deflection coefficient as 2 here. So let me write 2 volt. Okay, now height in centimeter is nothing but we will count the number of boxes here. So let us count the number of boxes. Let us set it properly. 1 2 3 4, and here each line is of 2. This line is for 0.2, and till here it is, that means 1 2 3 4 4.4. so I can write it as height is as 4.4. just let us multiply it, it will be 8.8. okay, 8.8 by root 2. when you do this you will get back this value. okay, so this is the at 3 RMS. now at 5, you can see when I just stop this, just I'm setting it and I'm stopping it here. okay, this button is the run button. so now your waveform is stopped. okay, now you can count easily. okay, 1 2 3 4 4.4. okay, just you can tabulate the values. This 2 is the deflection coefficient. okay, and this is the height. so when we multiply these two, it will become 8.8. okay, this is the RMS value we set from the multimeter. okay, we just see in the multimeter, right? multimeter. okay, this is the reading. 4.4 is the this height. okay, from here to here the height is 4.4, and we multiply. so each box is of size 2. so when you multiply this, it will be 8.8. okay, 8.8 by root 2 becomes how much? Just now set the multimeter to the 5 volt, like this. We'll make it 5 volt here. This is 5 volt. We'll make it 5 volt. It will be okay, 5 volt exactly. So it is 5 now. Okay, done. Now we'll see okay, now the RMS value is here 5.14. now we'll check the CRO. let us go to the CRO, and it was stop. okay, when I click run, so previously the light, it was stop. okay, when I click back run, now the waveform size is increased. okay, now I will position it to some reference level. okay, here this line is a reference level, suppose. okay, so let us okay, stop. now let us stop it, and we'll count the number of boxes. it will be 1 2 3 4 5 6 4. it is 1 2 1 2 3 4 5 6 7 7 point and on 7.2. so we'll write here. So here we'll write it as deflection coefficient is again 2 and 7.2. so multiply this, it will be 14.4. just take it 14.4 by root 2. so you will get the answer. okay, similarly we will do for the other values. Let's make the value to 7 peak RMS. so let us go back to the CRO. okay, now just unclick this run button, so it is stop here. okay, and when I unclick it, it will start. okay, now you can see the waveform size is increased. okay, so how to get back the waveform in our prescribed area is by we will increase the voltage, this one. okay, now when I change the voltage here, now this will change to 4. okay, you can see it is changed to it will change to 5. now the 5 will decrease, but we will multiply this height with this. okay, so the ultimately the value will be the same. value will be increased. Okay, got my point. Okay, so let us stop this. Okay, we'll position to the reference level. Let the position to the reference level. Okay, then we will stop it. You can see 1 2 3 4. Okay, and 5 is the deflection coefficient, so I can write here 4 and the deflection coefficient is 5, so 5 4s are 20, so 20 by root 2. Okay, same way I can do for the 9. And now from potentiometer, okay, just make it 9. Now let us run this, so it will just make it to the reference level. Okay, 1 2 3 4 5. Okay, so again it is 5 multiplied with 5 will be 25, so you will just write 25 by root 2. Just you can solve it. Okay, so here we complete the first part. The number of boxes, you can tabulate the values. So this is our second part. Here what we are doing is we are measuring the AC voltage frequency. Okay, so in this first parameter here we were measuring the AC voltage magnitude. Okay, we were measuring the magnitude, yes or no, from like if measuring from peak to peak magnitude. Now what we are going to measure is in this part we are measuring the voltage frequency. Okay, so suppose this is one time period. Okay, from this point to this point we will measure. Okay, or from this peak to this peak we will measure the time period. Okay, time period F is equals to 1 by T. Okay, the time period is nothing but the inverse of frequency. We take the inverse, then it will be converted to the frequency. Here this part, here you can see this part is, this is the function generator. Okay, what you see in the figure, first explanation, function generator, we can generate the frequency. Okay, here we are providing V peak to peak of 4 volt from the function generator. Okay, and we are applying to the CRO directly. So we don't want any multimeter here, any power supply, nothing. Okay, just we need frequency generator, and that too we will set the value to 4 peak to peak, peak to peak to 4 volt and CRO. Okay, so let us start the experiment. So measuring of AC voltage frequency generator and CRO. Here this is the function generator. Okay, from here I can give the frequency. Okay, from here I can set the amplitude offset. So I can set the amplitude from this knob and frequency from this knob. Okay, or just click the 5 0. So let us just start with the frequency. Okay, so enter the frequency is 50 hertz. Just write 50 and click the button hertz. It will be 50 hertz. The 50 hertz. This is the frequency, and the amplitude is 4 peak to peak. Okay, let us see the CRO here. We will set the peak to peak to the 4 volt. Okay, 4 volt means how we can set it to 4 volt. So here it should be 1 volt, so that there should be how much boxes? 4 boxes. 4 into 1 becomes 4 volt, right? It is peak to peak, not RMS. Okay, it is peak to peak value, not RMS value. Just remember this. So zoom out, zoom in. Okay, so it is 1 2 3 4, approximately it is 4 into 1 becomes 4 volt peak to peak. Okay, now the amplitude is set. Now we are not changing the amplitude. Okay, we're not going to change the amplitude. The amplitude is set here, and we will just change the frequency. Okay, now the frequency is 0.05 kilohertz. Okay, what is 0.05 kilohertz? It is 50 hertz, okay. And we can write TB here also with the time coefficient adjusted, period of time, let me go here, okay. So you can find here TB is time coefficient, deflection coefficient, okay. And the periodic time method means just what we'll do is we will take the length, okay. Now previously we were taking the peak to peak. Now we are not taking peak to peak. We are taking peak to peak, but from one peak to another peak, okay. This we will take as a L, okay. Just multiply again, it will F is equals to 1 by T. So 0.05, let us write 50 hertz. TB is the time deflection adjusted, okay, and L is the length. That means peak to peak, one peak to another peak, okay. So let us stop the waveform. Stop, okay. So from this knob I am adjusting the time period, okay. So from this knob I was adjusting the amplitude. Here the amplitude is set down, okay. 4 boxes, 1 into 1 is 4 volt. With this I can adjust the time period. So okay, here you can see I'm stopping here. So from this point to this point, how many boxes is there? Here to here it is, from one peak to another peak it is 2 boxes, okay. So here what I am going to do is I will write, so let us, previously we were writing the voltage here, now we will not write the voltage, we will write the time period, because we are dealing with that frequency now. So time deflection adjusted is 10 or 20, it is 10, right? 10 millisecond, and the length is 2, so that means it will be 20. So F is equals to 1 by T. 1 by T is 1 by 20 becomes how much? 1 by 20, it is how much? 0.05. 0.05. These two value will be same, because this is frequency what we are applying, okay. This is the frequency what we are seeing in the CRO with respect when we convert from time period to the frequency. 0.1, let us so 0.1 kilohertz, 0.1 kilohertz is 100 hertz, okay. 100 hertz means, let us take here, so it is running again, okay. From here to here we have to take, okay. Let us set it properly, moving slowly, okay. Stop, okay. So from this point to this point it is how much? Again it is, let us see here in this arrow, how much is the time coefficient? 10. So time coefficient is 10, and time coefficient is 10 here, and time period it is how much here? 1 box, it is 20, sorry, how it is 20, 1 into 10 is, it will be how much? 10. So 1 by 10 is 0.1, okay. Same way you will get all the readings, okay. Just note down the values. Now let us set to the 0.2 kilohertz becomes 200 hertz, okay. 200 hertz. So let us take, now see that the time period is compressed, okay. So let us increase the time period from there, so it is now 5 milli, okay. So set it, stop. Okay, now it is stop, okay. From this point to this point it is 1 box into 5, so let us write it as, it is 5 into 1 becomes 5. 1 by 5 is nothing but 0.2. Okay, same way make it 0.3. So 0. Not 330 to 0.3. 0.3 kilohertz become 300 hertz. Okay, 300 hertz output will be stop. It is around 1.8. Okay, so here you will write what is the deflection coefficient here, 2 millisecond. Okay, 2 millisecond into 1.8 around 1.7 or 1.8. Okay, let us make 4. It is now 0.2 millisecond, very small. Okay, frequency is time period is small, means frequency will be more, right? So it is how much now? From this point to this point, it is 1. It is coming at this point. Okay, so it is 1.4. So I can write it as the 0. The deflection coefficient is 0.2. 0.2 into 1.4. Okay, so let us change the frequency. It was 4 kilohertz, now it is 7 kilohertz. Okay, still we have to change the time period. Okay, it was 0.2. What is so let us make 0.2 and so stop. It will be 1. Not exactly 1. Okay, it will be 1, not 0.7 around. Okay, so let us write it as 0.2 around, let us write 8. Okay, you will get approximately right. Okay, and 10 kilohertz. 10 kilohertz and run this. Okay, it will be how much? So it is 1 box into 0.1. So we'll write it as it is 0.1 into this is 1 box, so it will be 0.1. Okay, so accordingly next. At 15 kilohertz now, 15 kilohertz, the output will be will be 1, and in between 1, 2, 4, 6, between 7 it will be 0.7 into 0.1. Okay, 0.7 into 1. Make the frequency 20 kilohertz. It will be 20 kilohertz. So now it is 50 micro. Okay, it was around 1. So let us set it properly. Boxes. Okay, so this is 20 kilohertz is 50 microsecond into how many boxes here? One. So this is length in 1 centimeter. Okay, so just multiply it and get all this result. Okay, and you can submit the report before due date. Thanks for watching the video. If you have any doubt, you can post message or you can email. Okay, thank you very much. Thanks for listening. Do subscribe to the channel